For section 10.5, it's titled Apply Other Angle Relationships in Circles. And this is really looking at, we've now kind of talked about central angles and their arc relationships thus far. These are going to be other relationships that exist within circles. So we really have three different types we're looking at. The first one we have is theorem 10.11, which says if a tangent and a chord intersect at a point on the circle, that'd be at point A, then the measure of the angle is half the measure of the arc. So we've talked about inscribed angles actually in section 10.4, and this is going to kind of follow the same idea. So I have this tangent and this chord that meet here, and I get an angle. Let's look at angle 1. Now imagine you're looking back at last section, and you have at angle A, at A you have this angle, and it matches up to some arc. If I open this up eventually so that it is a tangent, I'm stuck with what I have here is angle 1. Now, using that same idea as inscribed, I'd have that angle 1 is half the measure of the arc, or the angle is half the arc. That's going to follow here as well. Angle 2 is half of BCA, its arc that matches to it. So, if we look at some examples, I have the arc is 130, I need the angle. Well, I take half of it, so I'd get the measure of angle 1 is 65 degrees. For B, I'm looking for now the arc, JKL. I need to double it now, and I get that the measure of KJL is 250 degrees. Now, those are pretty easy. Let's go a step further and look at filling in everything else. If, let's say I know this is 65, the angle next to it is its supplement, so I could subtract 180 from that and get 115. And then if I doubled that and got its arc, it would be 230, which together with 230 and 130 would give us 360. So that fits. Over at B, we have 250 here. Well, 360 minus 250 would be 110, which would be this arc over here. I then take half of that and find that this angle would be 55, which together 55 and 125 would be supplementary. So we can even check them that way. So look at a couple more. I need angle 1. If it's 210, I take half of it, and I get that measure of angle 1 is 105. For number 2, RST, I have 98 as its angle. I have to double that, and I get 196. For its arc. And then last, arc XY, the angle is 80, so the arc is 160. Now, the next type we have, and this isn't going to be too much related to inscribe, but this is when we're looking at angles inside the circle. Here we say if two chords intersect inside a circle, before we go further, it's just saying they intersect. Does not say it's at the center. If it was at the center, they'd be central angles, and it'd be a different problem we would have already addressed. All we know now is they just meet inside the circle. So, two chords intersect in a circle, nowhere in particular, just inside the circle. Then the measure of each angle is half the sum of the measures of the arcs of the angle and its vertical angle. So, let's look at our diagram on the left here. I have angle 1, and I think it'd be fair to say that this could also be angle 1. Now, we usually don't call angles by the same name, but whatever angle measure angle 1 is, this one would be the same because it's vertical. Now, each of those angles have an arc to it. This one has DC, angle 1 on the right. This one has AB. By what it says here is it's half the sum of the measures of the arcs of its angle and its vertical angle. So that means angle 1, either one, is equal to 1/2 DC plus AB. Okay, so that's what we have there. We can see that. Now if we do the same thing for angle 2 and its vertical angle, we have arc AD and arc BC. And arc angle 2 is 1/2 AD plus BC. So here we can even see that the angle is equal to arc 1 plus arc 2 divided by 2. Now really this is the average of the two, but it's also the number in the middle because we're really looking at the two numbers. Now, we won't always have to find the angle. Maybe we'll have to find the arc. So maybe this is a better idea to heap. We're adding them, dividing by 2 to get the angle. Then we can just plug in the values we need. Keep in mind as we go forward, I'm lining up these values, these vertical angles and their arcs, these vertical angles and their arcs. Something we're going to see, at least on our examples, how it's important to remember where they line up. So let's jump over to our examples. I have x.
Patrick Bowman, please report to the Counseling Center. Patrick Bowman, please report to the Counseling Center.
X is my angle. That's equal to 130 plus 156 divided by 2. X equals then 286 divided by 2, or 143. So that is this angle right here. Now, in the next one, I notice I have this 102, but then y and 95 don't really match up. That's not an arc to those angles, and that's something we have to pay attention to. We don't really have a way to find BC or AD. We don't. We're kind of stuck here. We're going to use this line, though, to help us. So I need to first find the angle next to 102. Its supplement is 78, so it's really either one of those angles, because we can use either one. And now I'm going to say 78 equals y plus 95 divided by 2. I kept with the same rule. Still use that, I just plug in what I know. I then get 156 equals y plus 95, and that gives us that y is, let's figure it out here, 61 degrees. Okay, let's try a couple more of these. Here I have x is my angle, 35 and 55. So x equals 55 plus 35 divided by 2. That gives us 90 divided by 2, or 45. Now if we look at this real fast, 45 is in the middle of these two, and that's really what we're looking at for the two values. Yes, it's the average, but it's also the middle value. So we have that one, 45 for our angle. And the next one, I don't have them all lined up. I have to find this angle next to the 138. 180 minus 138 gives us 42. So now 42 equals x plus 50 divided by 2. That's 94 equals x plus 50, and I get x is 34 for my arc. Now, the last one we have here, we just kind of snuck in. This is one we looked at earlier. If we have the arc, we want the angle, we take half. It is 55. Okay, so that's when angles inside the circle, add the arcs, divide by 2. The last one we have is angles outside the circle. Here we have three scenarios. We have a tangent and a secant, that's this case, two tangents, that's this case, or two secants, which is this case. They all work the same way, but now notice the angles on the outside. So what it says is the measure of the angle formed is 1/2 the difference of the intercepted arcs. So before we took half the sum, now we're taking half the difference. So in the first one I have AC and BC as my arcs. I'm going to take BC, subtract AC. This arc minus this arc, divide by 2. In this one I take PQR minus PR divided by 2 to get the angle. In the last one I take XY minus WZ divided by 2 and find the angle. We can really sum this one up because the angle that's outside, we'll add that little note there, is equal to the big arc minus the little arc divided by 2. Now, you're not going to do the little arc minus the big arc because that'll give us a negative value, but it's big arc minus little arc divided by 2. So let's try that. In our first one, I have x is my angle, big arc is 178 minus 76, little arc divided by 2 gives me the 102 divided by 2, or 51 degrees. Next one. Now, this one we have to be careful because some students tend to pick 44 as the big arc. It's not. We can clearly see A is the big arc. Keep in mind the bigger arc is always further from the angle. But we get 30 equals A minus 44 divided by 2. That becomes 60 equals A minus 44. I then add 44 and I get 104 is equal to A. There's a couple more for us to look at. We're going to take our angle, 75 is equal to the big arc minus the little arc divided by 2. Here in this case we're just solving for x. So I'm going to multiply over by 2 here. What I could also do is simplify this. It actually becomes, well, let's just write that out. If I subtract 5x, I get 7x plus 3 over 2. But I'm going to multiply over by 2, mainly because of the fact that 7 and 3 are both odd. It kind of gives me fractions. I want to just multiply by 2. I get 150 equals 7x plus 3. Now it's a little easier to solve and I've avoided fractions. I subtract 3 from both sides. I get 147 equals 7x. Divide both sides by 7 and I get 21. Now in this next one, 110 is not my big arc I'm looking at. I need this arc here. That 110 is not inside the angle. What I'm going to have to do is add 110 and 92 to get 202, which is the total of these two. Then subtract that from 360 to get what's left over out here, and that is 158. So now I can say that my angle, in this case 10x plus 3, is equal to 158 minus 92 divided by 2. Now 158 minus 92 gives us 66 over 2 equals 10x plus 3. In this case, I am going to divide the 66 by 2 just to make it smaller. It's even, makes it nice. 10x plus 3 equals 33. 10x equals 30, so x equals